Well, hello everyone, and welcome to our survey dedicated to the AC and engineering community. My name is 5 years. I'm head of engineering. I have a background in civil engineering and spatial data, and I'm joined today by my colleague Peter Slater, who's also a civil engineer. And before joining Fathom, was working at Mott MacDonald. So we're here today to make the session really informative for you. And to give you really a broad understanding about Fathom, our data, our climate data sets, but importantly, to help you as engineers really apply the data to your projects so you can derive value from the data sets that we provide. And we want to give some examples and use cases here of how our data is being used in the real world. So we'll have, at the end of the session, we'll have a Q&A session. We'll be able to answer your questions. So you'll see in your little panel on Zoom a button with Q&A. So can I ask you please to put your questions to us via the Q&A panel as we go through the webinar. If you put them in the chat or anything else, we won't see them. We won't be able to respond to them. So please, if you have any questions, and we welcome them, please put them in the Q&A panel and just we'll collate those and we'll cover them at the end. Okay, so before we dive into the main detail of the presentation, what I'd like to do is just give you a bit of an overview of Fathom for some of you who may not have come across us before. So Fathom, as the business, was set up by 2 PhD students at our neighbours, the University of Bristol here. And they were looking at research and developing flood models, and they realised that actually the research they were working on could really benefit a number of organisations and communities globally to provide and develop data sets, particularly in data poor areas. So the business was set up, and as a result of the academic background, Fathom publishes all our methodologies and validation in the world's leading scientific journals. We make all our peer-reviewed papers available on our website. And if you really want to understand the science we apply to our modelling applications, please, I would encourage you to go to our website, have a look at the papers. There's a lot there, and hopefully that will give you a good understanding and background on the science and the methodologies that we apply. And there's also a number of papers there looking at validation and how we compare our data to other data sets out there. So my colleagues will share the link to the papers on our website via the chat panel. Okay, well, let me hand over to Peter.
Thanks, Gavin, and hi, everybody. So on screen are some of our clients. What is driving this increased demand for flood intelligence? Well, our work with the World Bank has shown that 1.8 billion people face significant flood risk globally. Yet large areas of the world have little to no flood risk data, whether that is for current or future climate scenarios. We know a warmer world means a wetter world. Our projections confirm this, illustrating increased precipitation levels across the vast majority of the land surface. However, interestingly, climate change is not the most significant driver of increasing human exposure to flooding. It's actually our own expansion of the built environment and modification of the natural environment. I think that's really pertinent for this call today. We as an industry have always had a responsibility to understand our impact on the world, but never more so than now. By 2050, our estimates show exposure and human exposure to flooding increases by 97%. And 75% of this is due to population growth and urbanization, and actually 19% is due to climate change. So in essence, these dynamics are driving an increased demand for consistent, comprehensive flood risk data globally. But let's dig a little bit deeper into this challenge and break it down. Many of you on this call, whether it's tendering or delivering work around the world, will have come across some or all of these issues when trying to understand flood risk and, importantly, make decisions off the back of that flood risk. Data is sometimes just not available. There is no data. The data that is available can sometimes be hard to access, whether it's requiring an application and a wait time, or whether there are technological blockers or format issues. The accessible data can sometimes be years or even decades out of date. It may not be clear what validation has been done on the data, all the methodologies that have led to the data. And even the good quality data, which is accessible, often lacks certain elements, sometimes missing climate projections or no climate projections at all, sometimes missing some of the pluvial, which is the flash flooding, the fluvial, which is the riverine flooding, or the coastal flooding from sea level rise and coastal storm surge. Or it may not have clarity around whether defences are included or not included. And when there are these gaps, often the sort of knee-jerk response is to commission a very detailed, local, sort of engineering grade flood study. However, as we know, this comes with significant time and cost implications. By combining world-leading expertise, continuous research with powerful computing and machine learning, Fathom provides a solution, a high-resolution, globally consistent view of flood risk. Full coverage at the scale, which was not possible before, and rapid access to the full range of pluvial, fluvial, and coastal flood perils, from return periods of 1 in 5 years to 1 in 1,000 years for the full range of extremities, and delivered in a range of industry standard formats. The ability to access the comprehensive climate change scenarios for the next 80 years has been a key driver in the uptake of this data. Yeah, and as Gavin alluded to, we're out of university, we're research led, and we don't operate a black box approach. By that I mean, we've published all our research. The methods are there to be able to be interrogated and looked at, and importantly, we also publicly publish the ongoing validation. So the comparison of our estimations with the observed and modeled events around the world, which is also important for reinforcement training and training the algorithms to improve. And it's critical for clients to understand how much work has gone into the precision of the data. And we're here to help. We work closely with our clients. We have several experts in different domains that are available to chat anytime with your end customer. I just want to talk about an example for a moment. On the left is some publicly available data from the Federal Emergency Management Agency in the United States. Now we support everything that FEMA represents as an organization. However, for engineering use cases, this example here doesn't provide the full picture. So in this case, it's lacking the depth information for the flooding. So as you can see, you just get a view of the extents of this particular fluvial event and not the depths. And as you can see, it misses several of the significant sort of tributary and pluvial flooding elements that you can see in our similar 1 in 100 year event on the right. Yeah, and it's not just in the States, even here in the UK. The Environment Agency, which is often cited as world leading in its publicly available flood data, often lacks large areas of pluvial data, coastal data, and has limited future climate projections. And look, it's the same with the National Emergency Management Agency in Australia, and we often hear stories of similarities across Germany, France, Poland, Southeast Asia, Latin America, and Africa. We've mentioned that traditional detailed flood modeling practices, for example, using two-flow BLE, Innovise, HECRAS, and those tools can be slow and expensive. It's not to say we don't recognize that they're critical when you need to get to a certain level of detail. They are. It's just that the industry needs to be able to immediately access broad-scale but high-resolution data for current and future flood risk that is comprehensive and transparent. So to solve these challenges, we focus on 4 areas, 4 solutions, comprising of both off-the-shelf data as well as bespoke services. If I can just get the next slide, please, unless I'm super, thanks. So this is the global terrain data that we provide, our flood maps at the global and national level, our risk scores, at the global and national level, and the catastrophe models. We're not going to talk about the catastrophe models too much today because they tend to focus on insurance product settings. So I'll talk about our global terrain data for a moment. FABDEM, Forests and Buildings Removed Digital Elevation Model, a globally consistent DEM, leverages the latest LiDAR and satellite data to create the leading global terrain model, which varies from 10 meters to 30 meters around the world. And this is used for much more than just flood modeling, as it happens. There's a range of applications. That's actually a very short list on the screen. We're seeing some real innovative uses of this data, and the important thing is it's stitched together, it's processed, and it's clean. Our next product is the flood maps. We provide this at the global level at 30 meters resolution, and at the national level in the US, UK, and Japan at 10 meters resolution. This provides the pluvial element, the fluvial element, and the coastal element. It provides separate views for defended and undefended. We're also releasing some 10-meter maps for new nations and continents soon to be announced. But it's not just the current view of flood risk that's important. Having the comprehensive view up to the year 2100 for all of those return periods, all of those perils, is really critical across the different delta T ranges and the likely climate scenarios at different severities, different uncertainty levels. The famous statistician George Box said all models are wrong, but some are useful. And the fact is, a useful model will tell you the level of confidence of its results. Fathom is the only organization which provides global confidence scores for its flood hazard and risk data. This is really brand new, only recently announced, a massive update and really exciting development in the journey towards transparency and openness. Sometimes having multiple different flood data layers is a bit too much information, and clients want to have an overarching view of flood risk across an area that combines both the hazard information and the local information, such as population densities, to get as you can see here, a sort of red, amber, green view of flood risk. Really helpful at the portfolio screening level, really helpful at prioritizing the areas of focus to dive down to do deeper assessments. And that's something that we also provide globally for relative risk and for risk category. I believe we've got our first poll coming up. Yeah, we really like to keep an eye on, and I'm really interested in your perspectives of, where are you seeing the most demand for flood risk data? A lot of this can be in the sort of traditional space around, flood and climate risk assessments, climate vulnerability assessments. I was actually having a fascinating discussion with somebody, an organization yesterday that's looking to map the propagation of malaria across Africa based on the increasing flood risk as it changes the habitat. But not only that, looking at providing mitigation strategies. So by understanding flood risks, they can look at the blockages of the transport links, the impacts on logistics, access to healthcare services, and all of that ties in to understanding the infrastructure being resilient to support communities who are affected by malaria and flooding. Yeah, I think as you can all see, flood and climate risk assessments really topping the group there. Interestingly, ESG and asset portfolio screening quite low. I guess that does make sense given the engineering focus of our audience. Super, thanks so much for that. I'll now hand back over to Gavin.
Thanks, Pete. Okay, so hopefully you can see the slides okay. If you could close the poll, that would be wonderful. Thank you. So Pete talked about how we can get access to the data. About our data sets. What I want to touch on really is how do we get access to our data? And part of that is we have three essential ways of data delivery. The first one is through our API. And we have developed an API for sharing of our data for instantaneous results of the data. And that API we've plugged into a number of spatial data platforms with large global engineering consultancies, and we'll reference one of those a bit later with Arab. But by accessing through the API, it's instantaneous access to not only the flood maps and risk scores, but also the terrain data that Peter talked about as well. So we have a number of different data sets that are available. And one of the really important things around the API is that we can create future flood maps for any time horizon up to 2100 under any recognized scenario instantaneously through the API. So that gives an infinite flexibility for provision of climate data and flood risk data to you as a user. So the other method is holding the data on premise. Some organizations want to access our data and hold that data on premise. And that could be for a particular project, it could be for a particular country, or it could be for the global data set. So we are able to provide access to our data. We provide it through Amazon buckets for you to download and hold that data on premise. Alternatively, a lot of our engineering clients work on a project-by-project basis and use our data accordingly. So by using that, they can order the data online on demand and share a shapefile with us or a polygon of the area of interest, select the relevant data, and we can provide that data out. We can cut it and provide it online for them to access. Okay, so where does our data essentially fit into projects? So we believe that our data really sits at the front end of projects and really to help you in that initial feasibility study, that prelim screening of the locations or the boundaries or the project. It could be that you're looking at various options or routes it could be a road or a railway, or it could be looking at funding options. What's the best way of funding, or where do we actually need to invest to protect the assets we're looking at? So by accessing the Fathom data through the API or online, you can very quickly get a very broad scale understanding of the issues of the project that then would naturally flow down through. And when you get into the detailed design phases, using the platforms like the flood modeler from Jacobs or TwoFlow or HECRAS, where you need to get and invest and develop those detailed models. But by accessing the Fathom data up front, it really gives you a good broad scale understanding of where you need to devote your resources. So that really gives an overview of actually where the data fits in. So let's look at where the data can actually add value. So there's a number of different locations there. Partly around, first of all, sort of site assessment, looking at linear assets, critical infrastructure we'll talk about, but also looking at that climate perspective as well, which is really important. But underpinning that, how do you actually apply the data? And I think, using our data in a number of different ways, looking at rapid access of screening of assets or infrastructure. This is where the risk scores really come into their own, to have that quick one and done view on a whole range of assets. And that could be in a state, it could be in a county, it could be in a country, it could be globally. So very quickly you can pass those assets against the risk score data and start triaging and identifying those assets that are higher risk. Once you've done that, that's where the flood maps really come into play, when you can actually get into more detail and understand, looking at those more detailed flood risk assessments using the flood maps. And then, of course, we look at sort of the whole climate resilience and adaptation piece of existing infrastructure. So again, this is where our data can really help projects identify those assets at risk and then develop mitigation strategies to offset the impact of those risks. So if we look at site assessment is a great example of the use of Fathom data. whether that's looking at assets, existing assets for acquisition or upgrade, or it's actually looking at new sites for development of new assets. But the idea is, with a desk study, you can very quickly screen assets and select and invest in the sites or the locations that are applicable. And that's not just the flood maps, that's also using Fathom, the global terrain data as well, in combination to help you look at these sites. And it might not just be flood risk, you might want to look at the access to the site, you might want to look at the aspect of the slope of the site. There's a whole range of other applications that Fathom can really support there. So this example is one of our clients who've used our data to review a set of assets that they actually acquired. In this case, it was a series of solar farms in the US. And when they applied our data, you could see that this particular solar farm had significant issues with pluvial flooding. Now, normally they would have just written the site off if it had any flooding, and they wouldn't go back to deal with it. But essentially, because they had this data, they were able to rearrange the solar array on the site and make it much more resilient to this type of pluvial flooding, and of course keep the operation of the site going, which is really important. So moving from sort of singular or small locations, really looking now at linear assets. So our data is really excellent where you have assets over very large areas, whether that's transportation, road or rail networks, it could be energy networks, it could be comms networks. But it's essentially overlaying our data across that network to identify those wet spots, to ensure that you can identify the issues and the problem areas across that network, not only today, but also under future climate scenarios, to ensure that you're investing in the right areas for looking at resilience and adaptation, but ensuring that maintenance regimes are monitored and updated to ensure that the overall operation of the network is kept up to scratch. Because these types of events obviously have significant impacts, and we've seen a number of those recently through various weather events. So our data has been used on a whole range of different projects. Italy on a series of large motorway resilience projects by one of our clients. It's been used recently in Canada to assess the suitability of a particular rail network for another client. And here in the UK, Network Rail is using our current and future data for the UK as an input to their climate assessments across the network. So that's hopefully given you a couple of areas of where our data can be used. So let's look at some real use cases from our standard off-the-shelf data. The first one here is one of the earlier projects we worked with Arab. It was a government project in Peru. All the critical infrastructure, the schools, the roads, the hospitals, were all significantly impacted by the El Nino in 2017. And this project was looking to basically build back better. How could they invest in that critical infrastructure, but ensure that it wouldn't be impacted by a similar event in years to come? So our data became essentially the benchmark across the whole project region. There are something like 7 or 8 different regions, as you can see here, there's one of them on the screen, where essentially we're able to identify the problem areas, and it was used to, the Fathom data was used to understand the impact of flooding and help redesign the location and the infrastructure, the location and the design of the critical infrastructure, and that project is still ongoing. We did a project a couple of years ago for the World Bank, looking at the flood vulnerability under climate conditions for Fiji. So we assessed the fluvial coastal flooding for the whole island, really to help inform developments and investment across the island in the local stakeholders to ensure that the resilience was developed to the impact of future climate change. And this was one of the number of projects that we've been involved in with the World Bank. Looking at something slightly different now, data centers is a growing area that we're getting involved in. And Microsoft uses Fathom global data to understand the impact of flooding, not only on their existing infrastructure, but when they're looking at investing and developing their global infrastructure. So they've developed a number of flood mitigation initiatives to reduce the current level of impact, and developed a whole series of protocols for new infrastructure development. By analysing the Fathom data during live events, they have what's called a dynamic contingency planning, and that enables them to provide rapid response to difficult and sometimes urgent situations. And so our data really helps assess, it's critical to assessing the risks for Microsoft's cloud infrastructure. And this way that the data really underpins the use of that infrastructure that's relied on by over 400 million global users, whether that's Office 365, Outlook, OneDrive, Azure, and of course the 48 million users of Xbox Live. So our data is one of those elements that really can kind of underpin the application, particularly for data centers. And as I said, we see that as a growing area. One of our partners, ERM, a large global sustainability consultancy, have taken our data, they hold it on premise, and they've developed a climate impact platform. And you can see here some applications of the platform and how it's used for clients. And so they can rapidly assess their climate assets in relation to a whole range of natural catastrophe elements, but particularly the pluvial and fluvial flooding. And they very quickly rate and analyse those assets on behalf of the client. Another partner of ours, Arup, have taken our API and developed their Iris platform. And this allowed very rapid flood risk assessments and climate assessments across the organization. And it's not just the use of our Fathom data for visualization and understanding the impact of flooding today, but also under future climate risks. And with the engineering data that Arup they have the ability then to look at the structure itself and also the potential losses accruing from those flood impacts. Pete, let me hand over to you to talk a bit about Tetra Tech.
Thanks very much, Gavin. I wanted to also take a look at the journey that we go on with clients. We originally started speaking to Tetra Tech in earnest in 2023 at the Flood and Coast event, and I was chatting to their head of flood risk management responsible for UK and Europe, and they were really keen to expand their operations in Europe from their UK hub. And so we went on a journey of learning with the client and really understanding the demand across different teams and some of the challenges that they were considering when thinking about this sort of business expansion. That's really critical to secure the buy-in, to increase the awareness, which is the next stage that we went on, running several technical sessions with our experts, with our head of hydrology, our head of climate change, with the people that are going to be involved and using the data. By providing sample data sets, people can get hands-on and then they can really understand the capabilities of it. And I definitely, when you're thinking about adopting this type of data at your organizations, it's always important to think about this journey and think, even on the surface, when it seems very, very like a clear, valuable route to progress from, taking these steps can really, really help. So we went through a stage of sampling the data, and most recently conducted the first pilot project providing data for current and future climate scenario flood hazards across 9 sites across Europe and the UK. And this is what we were talking about before, the market is changing, where clients want to be able to compare apples with apples, not just across watershed boundaries, not even just across national boundaries, but almost across continental boundaries as well, so that they can have a clear understanding that the decisions taken off the back of the data are based on a consistent approach to understanding the risk. We're in the process now of selling the API up with Tetra Tech. I was at an event recently listening to the head of climate resilient infrastructure at Tetra Tech, who spent his life working internationally, and he was saying that the impact of this climate change, particularly in sub-Saharan Africa, are really significant. So communities there often have 2 residences that they live in, depending on the whether the rainy or the dry season. A residence that is in the floodplain, a residence that is out the floodplain, and they'll move back and forward, and they'll have boats set up at particular places to transport the communities between the 2. And that's been fine, but now the flood extents are changing, and the boats are in the wrong place. The second houses are no longer in and outside of the floodplain, and it's really caused a whole community shift. So better access to the future flood risk helps at the grand scale, and it helps at the individual community scale. I was also speaking to the president of Tetra Tech recently at an event, and she was over from the United States, and I said, "Oh, what brings you to the UK?" Which I guess was a bit coy, but she sort of smiled and directly said, "Well, in my opinion, Tetra Tech are the leading water provider, a water advisory engineering provider in the United States, and I want to see them become that in the UK and in Europe." And I thought, wow, okay, that's a good ambition, and having access to these types of data sets is a key part of enabling the expansion into new markets and providing consistent services to clients and expanding service provision as well, which we'll briefly touch on later. And it's exciting to see Tetra Tech move towards a business as usual stance point now with this data. So this is a project that we worked on with KPMG and one of their partners called Augment City. And you'll know, and when I used to work at McDonald and Costain, this idea of securing stakeholder buy-in for planned urban developments was just a really, really critical part of progressing things forward, of getting through the hurdles of community engagement. And this particular tool looks at informing city planners and local authorities of the risks and opportunities associated with new development plans by bringing in high quality, consistent physical risk data to embed alongside the 3D visualization of the existing and planned developments. And you know what it's like, once you bring data into a platform like this, it's very quick to then iterate different options, to get people around the table, moving around the model, understanding and problem solving. And, this doesn't just go for flood risk data as well. It's the same with extreme heat. It's the same with wildfire risk. By bringing these data sets in, having an understanding of the data provenance, combining it with the planned mitigations, you can quickly go through the design optioneering process. And up until this point, it just wasn't possible for these entities and these different parties that were trying to provide solutions to get a real view of the overall risk and opportunity landscape. So we did this for a site in the UK and for the US, and we're looking forward to further applications of this around the world as part of KPMG's net zero program and Augment City's a position to support that. This one for me is a fascinating project, and which I haven't actually put the name up for. It's called Credo, the Climate Resilience Demonstrator. When I worked at Costain, I worked on the London Power Tunnels project, which was you may not even know about it, but it's about 30 to 40 kilometers of new tunnels under London, where the new super high power cables are being laid to protect them from all sorts of risks. But what cities don't typically understand is what is the failure dependency between these different systems of systems. If the substation floods, the power's knocked out. what happens to the local water pumping stations? What happens to the telecommunications systems nearby? And exactly what flood levels does it occur? How long do we have? All of these questions that come up are both of national and international importance. So what we did was we worked with BT UK Power Networks, Anglian Water, and several other partners to develop a simulation tool that takes into account both the dependency between different systems as well as the physical risk data. So we provided the flood risk data for several different scenarios, combined that with what was called a sort of an ontological based sort of knowledge dependency graph, to show the organizations involved at what different severities of flooding different assets would fail and what was the consequential knock-on to other assets. And this is really starting to breach the boundary between typically siloed utilities, the way that they fund, build, design, and looking at the systems to systems approach to providing resilience to cities and providing resilience to communities. It's a really interesting project, which is now moving on to include transport as another interdependent system, and really just move on from there onwards to add in more and more different systems and create a scalable architecture. I believe we have our next poll. Yeah, I mean, you've heard from us on the feedback we get from clients about some of the challenges that they have in this space. Do you agree with it? Do you disagree with it? What's been your experience to date? And if you have an answer actually that isn't on there, feel free to put it in the Q&A and say, for poll 2, I actually have found X, Y, and Z is important challenge for me, my colleagues, or our organisation. I'm actually very interested in the results for this one. Accessibility. Apparently I had my camera off for all of that. I do apologise. Not that you need to see my face, but you can now. Accessibility at the top, resolution, cost budget. Now that makes sense. Future climate projections. Interesting. Transparency and methodology, not too high. Very interesting. But it makes sense. We live in a world of data that often we can't get our hands on. So thank you very much for contributing to that poll. Really interesting.
Okay, thanks, Pete. Hopefully that's given you some flavour of how our data can be used, our standard off-the-shelf data can be used. What I'd like to do now is give a couple of examples of how our data can be used where we do what we call bespoke modelling. So to create our data sets that we've talked about earlier, we have a very large and sophisticated automated modelling framework. And that allows us to run models very quickly for large areas at a quite high granularity. So we've deployed that modeling framework, and a number of our developers and research scientists and flood modelers here to look at a couple of really interesting projects, which I'm going to talk to you about now. So the first one was in conjunction with Arup and the World Bank, focusing on Dar es Salaam. So the issue, one of the key issues with Dar es Salaam being a coastal city, is significant amounts of rapid and unplanned urbanization. Essentially, the population is due to double in the next 20 to 30 years. And a lot of that is in areas that are unregulated and uncontrolled. So because of the urbanization issue and then the additional issues of existing flooding, but also the flooding exacerbated by climate change and urbanization, that also causes additional problems like erosion, sedimentation, water availability, but also with climate change, the impact of the urban heat island as well. So we joined forces with Arup to really look at how we could mitigate and come up with options to mitigate those impacts of climate and flooding. So what we essentially did was we provided the team at Arup with our future flood data set for Dar es Salaam. They then identified the areas of additional urbanization between the present day and 2030 and 2040. Well, they then gave us that information. We ingested it into our model, the model framework, reran the model, and provided them a view of flooding today and under several different future climate scenarios and urbanization scenarios. So we were able to provide them a view of the impact of both climate change and urbanization on flooding across the city. They then took that and used that again, essentially as the backdrop or the benchmark to understand, okay, where do they need to apply mitigation strategies? And specifically around the application of nature-based solutions. So they developed a number of options for nature-based solutions. They provided that information back to us. We put it through the modeling framework, reran the model, and came up with this, where we could identify areas that were specifically benefiting from the application of those nature-based solutions to mitigate the impact of both climate change and flooding. So not only was it purely flooding, there were a number of other benefits that by 2030 looking to be realised, whether that's reducing the amount of buildings impacted by flooding. You can see there the reduction in the heat island effect, the ability to absorb water in the soil, and reduce that soil loss across the city as well. So there are a number of benefits that came out from this project, and it was a really good example of how we can work together with partners using our modelling framework to give what-if scenarios around things like climate change, urbanisation, and other future projections. So that was one project. This is another project that we have been working on for the first phase, and we're now into the second phase of the project, working with the Texas Water Development Board and Aqua Strategies and Aon. So the first issue here was that the Hurricane Harvey hit Texas and effectively caused catastrophic damage across the whole state. The state legislature felt that actually they couldn't plan for this type of impact again. So they needed to future-proof the state to ensure that if such an event hit again, and it probably is likely to, that they could actually be more resilient to these types of events. So one of the key elements there was really understanding the impact of flooding across the state. And when they pulled all that data together, effectively they realized that over 60% of the state was literally unmapped with any flooding information at all. And the flood data they did have was, and in their terms, what they called a quilt, a patchwork quilt of data sets, as you can see here, where the different data sets were overlaid and you had different methodologies, different resolutions, different temporal elements around the data. And so they did not have a consistent view of flood risk across the whole state. So that's where we got involved. They'd recently had flown the whole state with LiDAR. We pulled that LiDAR together and created a totally new, clean terrain data set for the whole state. We then ingested that in our modeling framework and reran the model based on this new terrain data and a number of other elements around local flood defences. And we produced a totally new flood map for the whole state. That was delivered in less than 6 months. And not only that, we provided them with the terrain data set as well. And that really filled in a lot of the gaps that they had in their existing data, as can be seen here, where they've got their existing data, and you can see the areas that the Fathom data really has filled in, both on the pluvial and the fluvial flooding. I was lucky enough to go out and speak to the Texas Water Development Board last year and meet some of the stakeholders, because this data has been passed out to, I think it's about 15 regional flood planning groups. And I met the leaders of some of those groups last year, and they were really very excited to have, for the first time for some of these guys ever, to have detailed flooding data, flood maps for their region. So they could start thinking about how they could invest in systems and defences and protection for their communities at a very local level across the whole state. As a result of the success of this, we're now working with Aqua Strategies and AECOM to deliver the next phase. And it's not only looking at remodeling with new LiDAR data, we're taking into consideration changes in land use and urbanization, but also subsidence due to oil extraction as well. And that data is due to be released later on this year. Peter, do you want to talk about how we work together with our clients?
Yeah, thanks very much, Gavin. I'll be a little bit lighter on this than planned, as I want to get to have enough time for questions. But we've been working with engineering organisations for a long time. We've both been at engineering organisations. We are really acutely aware of the way in which you like to work. This is why we have free sample data sets available, so you can get hands-on with your teams, so you can really understand the data capabilities. Just speak to us to get access to those. We have test access to the API. This is all about measure twice, cut once. Make sure you're comfortable with it and you understand it, and you'll realize the value in your particular context. We do a lot of show and tells. Our experts are used to presenting to some of the largest, most important organizations in the world, and that's where we can really get down into more of the detail, which we haven't covered on this call because we've run several webinars about exactly how we do what we do. Things like the machine learning channel solver. How do we do the confidence score metadata? How do we represent defenses, climate dynamics, and much, much more? So please do ask us to join those and help out. We have a customer hub where we can invite you to review the documentation and get a real better understanding of technically what's under the hood. Gavin's mentioned the research papers, and I believe a link's been shared with you to review those and check those. We have several industry insight articles talking about, what's this data saying in specific industries with specific contexts. Really great to reference for any of your tenders and your applications. So I highly recommend, please do book a session with our experts now, and a link will be shared with you to do that. We're always really keen to talk. And all this leads on to, where's the value for you as an organization? We've talked about some of the clear value of using the data as it is, but it's broader than that. And it's really good to think strategically about this sort of thing. So for example, the available funding globally for climate adaptation is increasing significantly. But with that comes some challenges, certainly for your end clients who may not fully understand, how to apply for this funding. Do they have robust enough physical data to demonstrate quantifiably what funding they need, how much they need it, when they need it by? Being able to be the vehicle that provides them that insight can really help them access more funding and help you all together deliver more value and deliver more work. We often see our data used at the actual tendering and bidding stage, whether it's to develop a greater insight into the likely solutions needed, even at that early stage. Or, for example, if you are an organization that bids for longer operation and maintenance type contracts, the 25, 30-year operate and maintain contracts, and you want a better understanding of the potential risks to the asset you're taking on, really great opportunity to do that at the early stages before you sign into anything for the long term. Think about your existing frameworks. There are opportunities to increase the services you provide. We often hear from clients who've been on frameworks for several years and aren't seeing the amount of work that they want through that. And it also applies to pre-positioning with clients. We run working groups very regularly where we invite clients. We invite you, and please do invite your end clients. And it can be a great way to build relationships outside of the traditional format, as well as with our webinars and panels. I think we're going to the last Q&A, the last poll, and then Q&A time. So that poll should say, what is the time frame in which you are likely to need this type of data? So is this something that you're currently needing? Is it something that you're likely to need in 6 months? Is it something you probably won't need for 12 months, 18 months, 2 years? This is just great to get an understanding for everyone on the call of of their colleagues, their peer-to-peer. Where are their peers at? Where's the demand coming? Where's the most likely time frame? And we always get quite an interesting result here. And yeah, now clearly sort of taking the lead now in 6 months. And some of this is regulatory driven. We know the SEC's just brought out their time frame for implementing reporting. We've had the TCFD change over to the ISSB. There's all sorts of regulatory drivers, but also in our industry, the simple fact that risk needs to be understood to provide a solution. Cool. Thanks very much for responding to that poll, and I'll hand over to Gavin to open up the discussion.
Great, thanks, Pete. And yeah, what we'd like to, we've already got a few questions, but I would encourage you to put any of your questions in the Q&A panel. Just before I do that, we're at a couple of events this year. We're at the Flood and Coast in Telford. So if you'd like to meet us and find out more, then please drop us a line, and we'll look forward to catching up with you there. And we're also at the ASFPM 2024 later on in June in Utah to meet up with a number of our friends and colleagues out in the US. And we're looking forward to getting out to Utah to do that. Notwithstanding, we're also attending a number of other webinars and online events with our partners. So please, if you are interested in us presenting to your wider audience or your clients, then please let us know. So let's get into some questions. Okay, so we have had a couple of interesting questions. One here from Saffron. What is the minimum of certainty that you consider good quality or good enough quality to publish or share? That's quite an interesting question. I think for us, we base all our methodologies on robust science. That's all peer reviewed, and so there's a certain level of confidence and ability in that. But essentially, we always validate our data against known data sources. So in the UK, we benchmark it against EA data, NRW data, and sometimes SEPA data when we can get hold of it. But and the same with FEMA in the US. And also in the US, we do a lot of benchmarking against data sets like the Iowa Flood Center. They spent many millions of dollars creating very detailed flood data sets for the whole of the state of Iowa, and they're a great benchmark for us to compare data against and how we perform. And that, we have confidence when we're looking at across a number of different of those data sets that how our data performs against them, and invariably there's a very good match. In addition to that, we also compare our data and validate our data against known events. Now, it's all very well talking about flood events. Sometimes it's very difficult to get a detailed, consistent view of not only the extent but the depths of flooding, because if you rely on remote sensing, how do you know when that particular camera or optical instrument has gone over the flood? Is the flood expanding or contracting, and what's the duration of inundation there? So we have done quite a bit of work in the States on a number of events, one of them being Hurricane Harvey, and we published a paper around the validation of our data set there. And we had a very interesting case last year, although obviously very sad and destructive case against the Hohova Dam in Ukraine. When that was blown up, we were asked by the Foreign and Commonwealth Development Office to do some very rapid modelling of that of the dam, and we modelled the inundation based on our modelling framework from the dam. We then very quickly compared that to satellite imagery that was made available to us, and we had a very, very good match between the flooded extent from the imagery and our modelled representation. So things like that give us confidence. And there's a question linked to this from Jasmine. we talked about uncertainty associated with climate data, particularly ensemble data. And uncertainty is, as Pete said, all models are wrong. Some models are more wrong than others. We're very keen to give people a good understanding of uncertainty. And in our methodologies, we talk about uncertainty quite a lot. Part of that is the reason we developed our metadata, and where you have the uncertainty or the confidence scores there, but also particularly when you're bringing flood models and also climate ensembles together, you're compounding that uncertainty. So that's why we provide different views on the future flood scenarios, not just the 50th percentile, but the 17th to the 83rd percentile, which is the proportion or the band that the IPCC recommend that people use to get a better understanding of uncertainty. So it's something we're constantly wrestling with. And I think one of the things that we're keen, and I would, from request input from you guys on the call, is how do we communicate the uncertainty? We obviously need to do it in a way that doesn't frighten people, but it informs people. And I think that's the balance we're constantly going through at the moment is really how do we communicate with people to ensure that that is the case. A part of that's through our scientific pedigree, and sometimes that's looking at specific locations and doing a one-to-one analysis. Okay, a couple more questions. One about resolution. This is something that we get asked quite a lot around. Okay, well, we've seen this data set and it's 2-meter resolution. It must be more accurate. And we're very passionate about this. The higher resolution does not always represent accuracy in the data. And that's why we invariably don't provide our data sets any lower than a 10-meter resolution, particularly in the US. We can increase that resolution where we've got better terrain data like LiDAR data, but when you're modeling, as we talked about, there's a whole range of uncertainties, and we need to ensure that we're not misrepresenting the flood risk and actually smoothing the areas. So it's really we don't model at very detailed resolution, partly because it could obscure the accuracy and the veracity of the data set. So we have got a video on our website talking about accuracy and resolution. And if you want to know more about it, then we can point you in that direction of that particular video because it is quite enlightening. Okay, let's see what other questions we've got. Okay, we've got another one here on licensing. I've just got one last question before we wrap up. How do we license, or how does Fathom license the flood data? So we, with license, the likes of Arup and McDonald and others, we have master services agreements in place with them at a global scale. And then we receive orders for the data on a project-by-project basis. And then all the licensing and the pricing are contained in the master services agreement. So it makes a very simple call-off order against that data, and the same for access to the API. So the licensing is relatively straightforward. For some of the end clients where we engage direct, they just have an end user license agreement that allows them to use the data internally and also share that data for their subcontractors to use on their behalf for the data. Okay, well, look, thank you very much. We're coming up to the end of our webinar. I'd like to thank you for joining us. If you do have any more questions, please drop us a line. We'll be sending out information and a link to this presentation so you can share that across your colleagues. And I'd like to just thank you for attending. Pete, any last comments to wrap up?
No, thanks for taking us through that, Gavin, and it's been great to be with you on this call, everyone, and hope to speak to you soon.
Great, thank you very much, and yeah, we look forward to meeting you either in person or online in the near future. Thank you very much for your time. Goodbye.